quickly draw up a solution. I'll either record myself doing the solution or send you the handwritten solution. But yeah, it just makes it difficult, or it takes a very long time to be taking up homework in class. But like I said, you feel free to email me, feel free to just contact me whenever. I am only teaching 2 grade 9 classes this class, so grade 9 is not that big of an issue right now. So like I said, feel free to email me, and yeah, that's about it. So yeah, like I was saying, you guys are basically done in 1 month of school. Thanksgiving's coming up, and you're basically into Christmas, so time is flying by fast. So we're going to talk about the second part of the slope of the tangent. So the definition of a slope of a tangent is, like we said from before, the slope of the tangent to a curve at a point P is the limiting slope of the secant PQ as the point Q slides along the curve towards P. Okay, so the slope of a tan such that x is equal to b is equal to the limit as Q approaches P of the slope of the secant PQ. So Q approaching P means that Q approaches, but it is never equal to P. Okay. So although we may have a graph or a curve, let's just say we have this curve over here. P may be over here. This is our original point. Q might be as close to P as possible, but it will never touch it. Okay? Because that defeats the purpose of a tangent. It can get as close as possible to it, but it's never going to touch it. Okay? Q never touches P. If there's any lag in the smartboard, just let me know. But I'll also be saving these notes. Like, the good thing about this is that I can write on this, I can save it as a PDF, and then you guys will have the fully written notes online as well. Okay, so technically, good thing, I'm very convincing and like to push. I pushed for a room with a smartboard because I didn't like the other room, and they gave me one. So I did it for the benefit of you guys, not for myself. That way you guys have more access to my notes, more access to, I guess, higher quality videos, stuff like that. So now we're going to talk about the slope of a tangent at an arbitrary point. So if a curve has the equation y is equal to f of x, and we want to find the slope of the tangent to the curve at the point P of a at f of a, we consider a nearby point Q, a plus h, and f of a plus h, where h cannot equal 0. Why can't h equal 0 in the difference quotient? What happens if we have h is equal to 0 at the bottom of the denominator? Yep, because Q cannot equal to P, and H also, if it's in the denominator of the difference quotient, it becomes 0, and therefore it is undefined. So we can compute the slope of the secant line. So here we have a curve with a point P and H, either adding it to the left or to the right. Okay. So obviously we have the slope of the secant. So M of the secant is equal to y2 minus y1 over x2 minus x1, or from our difference quotient f of a plus h minus f of a over a plus h minus a, and this is how we derive the difference quotients, and we get f of a plus h minus f of a over h. Okay, so this is what we're going to be using most of the time. So again, remember that we're going to be using a plus h and f of a. Okay. So the slope of the tangent line to the graph of y is equal to f of x at the point P is just the slope of the tan such that x is equal to 0 is equal to the limit as h approaches 0, where f of a plus h minus f of a over h. Again, we touched upon this last lesson, so this is just getting you refreshed as we move along. Why is this not? In 2 seconds. So now we're going to do some examples. So we want to determine the slope of the tangent to the function y is equal to x squared minus 3x at the points 1 and -2. That's for A. And for B, we want to determine the equation of the tangent at x is equal to 1. So what are we going to use to figure out the slope of the tangent at the function x squared minus 3x when the points is 1 and -2? What are we going to start with? Anyone want to tell me what we're going to start with? Okay, so we're going to find the slope of the tangent where x is equal to 1 because of our points. Okay, so this is then going to equal, so we have to find the limit as h approaches 0 of our function f of a plus h minus f of a over h. Okay, sorry, minus h, my mistake. So remember our points P is written as A and F of A. So this is written as A and F of A. So in order for me to continue, I'm going to plug in the number 1 wherever I see A in the bracket. Okay, so technically we're going to find the limit as h approaches 0 for f at 1 plus h minus f of 1 over h. So what we're going to do now is we're going to take our function y is equal to x squared minus 3x, and wherever we see our variable x, we're going to sub it with 1 plus h. So what we're going to be left with is equal to the limit as h approaches 0 of, so square brackets, we have 1 plus h squared minus 3 times 1 plus h minus whatever f at 1 is, and we know f at 1 gives us -2. And that's all over h. So I want somebody, or I want all of you, to simplify what's in the brackets. So a became 1 because of the rule that I talked about in the beginning. So if you want to find the slope of the tangent to the curve at a point, we know that if I go back down here, our point is written as P of A, comma, F of A, okay? So basically, the x value of the point that we want to find the secant at is referred to as A, and the y value is referred to as f of A because we're finding the value of that function at that specific A value. Okay, so here we have A, which means my x value is my A value, and this is my f of A. And that's why I was able to sub in the 1 for A. Okay, feel free to ask questions as we go along. But was anyone able to simplify what we had in the bracket over here? Let's see if you can either say it out loud or try to type it out, even though it's going to be weird typing out a limit. But it's up to you guys. And see if anyone was able to simplify that. Give you guys a couple of minutes to figure that out. Yeah, I don't mind waiting. So if you need extra time, I'll let you guys try to figure out to simplify the numerator of this limit.
Sorry, sir, I have a question.
Yep.
So I'm wondering why it says -3 bracket 1 plus h if the formula is -3x and x is only equal to 1.
So wherever we see our variable x, we have to sub in a plus h, okay? Because of this part over here of the quotient, okay? So it's f of a plus h. So wherever we see x, we're going to plug in a plus h. But since a is equal to 1 in this case, we have to sub in 1 plus h for x in our original function that we're looking at.
Oh, okay, thank you.
Yeah, you're welcome. So Madge got 1 plus h squared minus 1 minus 3h all over h. I'm just going to check if you're correct. Yep. So we have, like Matt said, 1 plus 2h plus h squared minus 1 minus 3h, and that's all over h. So as you are going to be able to see, there are going to be some terms that can cancel each other out. So my 1's cancel each other out, and that's about it. So, and 2h minus 3h is just negative h. So what I'm left with is the limit as h approaches 0 is negative h plus h squared all over h. I'm so used to writing over 2 with my grade 9, so my bad if I make some silly mistakes. So what can we factor out from my numerator? We have negative h plus h squared. What can I factor out? We're going to factor out the h, okay? The reason why we're factoring out positive h is because h squared is positive. So this is going to give us the limit as h approaches 0. Factor out the h. We are left with negative 1 plus h over h, which means that our h's cancel out. So as h approaches 0, I can just sub in 0 because it's approaching 0, which means that we get negative 1 plus 0, which just equals negative 1. Okay, so what does my limit usually imply with this in regards to the slope of the tangent?
Wait, where did the h go?
So the h, because it approaches 0, I can just sub in 0 for h.
Oh, okay.
So with my limit, what am I able to find with my limit? It's the first step that we did. What is the limit telling me that I'm finding? The slope of the tangent at that specific point, okay? Madge?
Do we have to write limit h approaches 0 every single time?
Unfortunately, yes.
Okay.
Okay. So now that we know our slope is -1, we need to determine the equation of the tangent line at x is equal to 1. So this is going to be our b. So we know our slope is -1, and our point is 1 and -2. Or what we learned on Tuesday, this is my x1, and this is my y1. So who remembers the standard formula to find the slope of the tangent line, or to make the equation of a tangent line? See if you guys remember. I used it around 4 times on Tuesday. Yep, y minus y1 times m bracket x minus x1. So we know my y1 is going to be -2. My m is -1. And I know my x1 is just +1. So now I'm going to get y plus 2 is equal to -x plus 1. Okay? And remember, we want to change it into standard form. So let's bring my x over and my +1 over to make everything nice and sweet. So we get x plus y is equal to x plus y, plus 1 is equal to 0. Or if you want it in the form of y is equal to mx plus b, we get y is equal to -x minus 1 as our equation of the tangent line. The only reason why this may be a bit tedious is because you're writing the limit over and over again. So this is why it may appear as tedious to do half the time. Okay. So again, we're going to do another example just to get you guys into the gist of things. And then I will let you do an example on your own. So we're going to do example 2a together, and then example 2b, I'm going to allow you guys to try and do it by yourself, and hopefully everything goes well. So like I said, I'm going to convert this into a PDF so that you guys are able to see the filled in notes. So the next one is determine the slope of the tangent line to each curve at the given point. So we have 2a, we have y is equal to 2x plus 4 all over x at x is equal to +2. So again, this is going to be my a, because remember our point is written as a and then f at a, which is why our a is going to be +2. So we're going to find the slope of the tangent where x is equal to 2, which means I have to find my limit as h approaches 0 of f of 2 plus h minus f at 2 all over h. The reason why this one might be a bit more difficult is because we're dealing with a rational function. Okay, and we all know rational functions are pretty annoying, mainly because of the denominator. So like I said, guys, wherever we see x in the original function, I need to sub in 2 plus h. So wherever I see an x, I'm going to plug in a 2 plus h for f of 2 plus h. And then for f at 2, I'm just going to calculate what f at 2 gives us. So this one's going to be a very annoying one because of the fraction. It's going to take up a lot of space. So I'm going to get limit of h approaches 0. So again, wherever I see an x in my original function, I'm going to plug in 2 plus h. So I'm going to get 2 times 2 plus h over 2 plus h minus 2 times 2 plus 4 over 2. And then this is all over h. So now I'm going to simplify and try to expand as much as possible so that I remain with a simple algebraic expression to work with. So I'm going to get the limit as h approaches 0. So I need to simplify my 2 plus h. So I am left with 4 plus 2h over 2h, over 2 plus h, sorry, minus 2 times 2, which is 4 plus 4, which is 8, divided by 2, which gives me 4 over 1. And so that's all going to be divided by h. So if you don't like fractions, I'll allow you to use the division sign to make it easier for you. But however, if you guys remember from basic fractions, I'm going to write this easy for you. What happens to the second fraction in division? What happens to it? What do we do to it?
Flip and multiply.
Yeah, so we take the reciprocal and then it becomes multiplication. Okay.
One quick question. Sorry to cut you off there.
No
In
worries.
your second like equal sign, did you like purposely lose the 4? The plus 4
Where's the plus 4?
from the original equation?
Oh, the plus 4 is, hold on. Did I mess it up? I think I did. Yeah, sorry. It disappeared by accident. Plus 4. Okay, so I get 8 plus 2h. Thank you for noticing that. So you get 8 plus 2h over 2 plus h minus 4 over 1. All right. So what do I have to do with my expression in the bracket? What do I need to do? Think of it as just adding and subtracting simple fractions. What do I have to do? Simplify? Okay, how do I simplify a fraction? What has to be done first? I need to find my common denominator. So can anyone tell me what my common denominator is for 8 plus 2h over 2 plus h minus 4 over 1? What would my common denominator be? It'll be 2 plus h, okay? So I don't have to do anything to my left fraction, but I have to multiply 2 plus h to both the numerator and the denominator of my second fraction. So what I end up getting is the limit as h approaches 0 of, so 2 plus h is going to be my denominator, so nothing happens to 8 plus 2h. However, I have to multiply 4 by 2h, so we get minus 4 times 2 plus h, and that will be multiplied by 1 over h. All right. And now we can just expand and simplify the expression on the left. So you get limit of h approaches 0 is 8 plus 2h minus 8 minus 2h. Sorry, minus 4h. My apologies. All over 2 plus h times 1 over h. So as you can see, some terms are going to cancel each other out. So we're going to get our 8s to cancel each other out. And then all we're left with is 2h minus 4h, which simplifies to negative 2h. So the limit as h approaches 0 of 2h, negative 2h over, because we multiply the second fraction over here, we get h bracket 2 plus h. So is there anything I can cancel out to simplify this even more? Okay, I'm going to cancel with the h's. So the h from the top cancels out with the h from the bottom. And we're left with negative 2 over 2 plus h. So as h approaches 0, I need to figure out what happens when I sub in 0 for h. I get 2 plus 0, which is equal to negative 1. Okay? So that means the slope of my tangent to the curve at that point is going to be negative 1. So now what I want you guys to do on your own, 2b is easier. So I want you guys to try and figure out how to do 2b. Yeah, the brain hurts its limits. That's what calculus is. But once you get the hang of it, you're gonna figure out that limits is just very easy. Okay, give me 2 seconds. I'm just gonna answer the phone. So for the 2 times 2 plus 4 over 2, how did you get negative 4 over 1? Oh, because of this subtracting sign over here, you get minus 4 over 1. No, the 2's cannot cancel. The 2's cannot cancel only because you have to factor plus 2, right? So when you cancel out the 2's, you're still left with 2 plus 2, which gives us 4, okay? That's the only reason why I wouldn't give you 6 is because you didn't take into account the 4. So that might have been a common mistake that some people make, but just be careful with that. All right. So like I said, I want you guys to do question 2B. I gave you guys the easier one, less writing to do. So for question 2B, what you're going to do is you have to find the slope of the tangent at y is equal to 5 root 5 minus x, okay? So I'm going to give you guys 5 minutes to try and do that on your own. If someone wants to share their screen after, if they're doing it on the computer, and show the class, that would be awesome. Okay, so I'm going to keep my my YouTube video short, so I'm probably going to stop recording here. And then I'll start the equation. So like I said, we start with the regular notation. So we're going to start with, we want to find the slope of the tangent, where x is equal to 1, okay? So 1 is also going to be our a value, which is equal to the limit as h approaches 0 for f of 1 plus h minus f of 1 all over h. So like I said, wherever you see x, you're going to sub in 1 plus h for f of 1 plus h, okay? So I'm going to stop recording here. And then, like I said, these will be posted fully notes posted, filled in. Once we're done with this lesson, I'm going to do lesson 1.2, part 2, filled notes, and I'll label it as that on Google Classroom. So I'm going to stop recording this right now just to keep the video short on YouTube. So yeah, so